in the concept of limits, there is what we call continuity of the limit functions and discontinuity of the limit function. Now, let us analyze this graph. Now, we say that the function is continuous at the interval -5 up to +6. Where is that? Here is the -5 of x and the +6 of x. It is continuous at that interval. And this notation states that -5 is in the domain of the function, as well as the +6 is also in the domain of the function. And we also say that this function discontinues when x is equal to -2. Why is that? Here is the -2, and the function is discontinuous there because we see an unshaded circle here, right? And at x +3, where is that? Because we also see an unshaded circle here. Okay, now we prove the continuity of this function. Now, continuity when x is equal to -5. Why is the function continuous at x -5? A, f of -5 is defined. As we have said earlier, -5 is in the domain of the function. So we write it here. -5 is in the domain of the function. Number 2, the limit of f of x as x approaches -5 is equal to what? So look at the graph, 2. In other words, f, the function f, has a limit as x approaches -5. Number 3, or we write C, the limit of f of x as x approaches -5 is equal to f of -5. Meaning to say, the limit value is equal to the value of the function. Or we write the function value. So we have proven the continuity of this function at the interval -5 up to 6, or we say the continuity at when x is equal to -5 on 3 grounds. We have proven the continuity when x is equal to negative 5 on 3 reasons. A, B, C. Or 1, 2, 3. Now we prove discontinuity at x equal to negative 2. When x is equal to negative 2. Why is the function discontinuing when x is equal to negative 2? Reason is this. F of negative 2 does not exist. Or we say that negative 2 is not in the domain of the function. As you can see on the graph, an unshaded circle is plotted when x is at negative 2. Now, we prove another discontinuity. The function discontinues when x is equal to 3. For the same reason, we say that f of 3 also does not exist. As 3 is not in the domain of f. So we have proven that on one reason that the function is discontinuous when x is equal to negative 2, and it is also discontinuous when x is at positive 3.